Hello everyone, my name is Nitya Kalyani. The topic I'm going to talk about today is challenges faced in HVDC system. Let us start from the beginning. What is an HVDC system? It is a system which is used for massive transformation of electricity in form of DC current over long distances by using UG cables or overhead transmission line. Names such as electrical superhighway or power superhighway is often used to describe it. Now, the electrical supply demand is increasing globally. Power plants are often located near to the energy sources to minimize costs and other environmental effects. These power plants are often located away from heavily populated areas such as consumer areas. Hence, transporting the electrical energy that is generated from the substation to the consumer area is economically and efficiently very important. This can be accomplished by transmitting the generated power at a very high voltage using an HVDC system. Let us talk about the objectives of an HVDC system. Bulk power transmission is used to transmit bulk power from one point to another point over long distance. Connect asynchronous systems, which allows transfer of power between grid systems that are running at different frequencies to improve stability and economy of each grid. Offshore wind farm integration, which simplifies bulk power transfer from offshore wind farms to large load consumption centers. And finally, back-to-back HVDC system, where rectification and inversion takes place at the same station with a very small DC line connected between them. Now, let us talk about the working principle of an HVDC system. In a generating substation, the power generated is usually AC, which can be converted to DC using a rectifier. Hence, in an HVDC substation or a converter substation, rectifiers and inverters are always placed at both ends of the line. Here, a rectifier converts AC to DC while inverter converts DC to AC. The DC is flowing through the overhead lines, and at end user, the DC is again converted to AC using inverters which are placed at the converter substation. The power that flows through the transmission line, which receives at the sending end and the receiving end, remains the same. Hence, DC transmission system is used for long distance transmission because it decreases the loss and improves the efficiency. A system which has two converter stations and one transmission line is known as a point-to-point system. If a substation has more than two converter systems and interconnecting DC terminal lines, it is known as a multi-terminal DC substation. Let us talk about some advantages of an HVDC system. It requires less number of conductors and insulators, hence it reduces the cost of the overall system. It requires less face-to-face and ground-to-ground clearance. Corona loss is less in DC system compared to an AC system, and power loss is reduced because it requires few number of lines for power transmission. Due to absence of frequency in an HVDC line, loss like skin effect and proximity effect does not occur in the HVDC system, and it does not generate or absorb any reactive power, so it does not need for reactive power compensation. Now, let us move to the actual topic, which are the challenges faced in an HVDC system. First is the electrical installation. A DC voltage is not always stable. It is switched on, it can be turned off, and the pure form of DC occurs only during for relatively short periods. Hence, need of electrical installation occurs for an HVDC system. A physical phenomena such as governing the electrical field distribution, mechanisms of aging, and electrical breakdown, it differs from those of an AC. In case of an AC voltage application, the electric field distribution is always capacitively distributed, while in case of DC voltage, the electric field distribution is more complicated, and different stresses and applications, they ask for new standards of qualification, maintenance, and reliability test for an HVDC system. Hence, the need to design and develop special electrical installation system for an HVDC apparatus becomes more and more important. Second is the current source converters. HVDC point-to-point transmission systems, they are developed using converter stations which are based upon mercury, and later they use thyristor valve technology. These are called current source converter, and they operate with a very stiff DC current. Hence, the voltage polarity needs to change, and every time the direction of power flow is also changed. The voltage inversion that is caused always cause challenges which can be rectified using a voltage source converter. Now, third is circuit breakers. The classical circuit breaker structure it combines series of mechanical and electronic circuit breaking devices which redirect a power surge in a current and then shut it off. Hence, the objective of a circuit breaker it is to obtain current zero crossing to interrupt the current, to dissipate the energies that is stored in the system and withstand the voltage response after current interruption. As existing HVDC breakers are capable of controlling HVDC current only for within several milliseconds, but practically they are too slow to meet the requirements of a reliable HVDC grid operation. And building mechanical HVDC breakers it is very challenging and requires the installation of additional passive components for creating the resonance circuit. In the present point-to-point HVDC transmission, DC interrupters are used at various different switching duties. The breaking time is in the order of 35 milliseconds, but for current source converter based systems, the increased inductance values they limit the rate of rise of fall current, and this time is not sufficiently very fast. And also, the components of these circuit breakers are large and they cost more than AC breakers for the same comparable current and voltage rating. Now, the other challenge that is faced in HVDC system is power loss. One of the problems of a voltage source converter system is the power losses, which means switching walls of the voltage source converter they are also responsible for large amount of losses. The anti-parallel diodes that is integrated with IGBT modules in a voltage source converter they act as an uncontrolled rectifier even if IGBTs are turned off. Due to this reason, the voltage source converter becomes defenseless against a DC short circuit fault and the fault is only limited by the AC side of the voltage source converter. And moreover, because of the small inductance of the DC side, in the VSC HVDC system, the rate of rise of the DC fault current is very comparatively high and even in some faults the capacitors of the DC link of DC discharge and thus contributing to fault current and increase in the rate of rise of it. Now, the last challenge that is faced by HVDC system is fault detection and coordination. Converters in an HVDC system must be very well coordinated in order to maintain a power balance, a satisfactory power transmission, and a solid DC voltage at the receiving end. Now, when a short circuit appears in a HVDC grid, the fault it will propagate through the DC circuit and appear at every converter station as a sudden DC voltage drop. Hence, protection systems of the converter stations will respond accordingly to interrupt the fault current and isolate the faulty section. Hence, a fast communication system between the converter station is required to provide selective fault isolation. Hence, selective protection system for HVDC grid they are also used to overcome the above challenges. Now, let us talk about some remedies for the challenges discussed above. A use of MTDC and supergrid. MTDC is a multi-terminal direct current system which has 3 or more DC converters that are interconnected by a DC transmission network. It has an architecture which is more complex compared to a point-to-point system, but it has much more advantages than a point-to-point system and it can be seen as a technology which is developed in the future. A supergrid is a large transmission network that makes it possible to trade high volumes of electricity across a great distance, that means between countries and continents. Many developing countries and continents they are adopting the concept of supergrid for transmission of electricity at a very high voltage to minimize loss and reduce cost. Supergrids are high voltage DC transmission lines which has a rated voltage greater than or equal to 500 kilovolt or ultra high voltage DC power lines, which is greater than or equal to 800 kilowatt. Now, to overcome the challenges that are faced in a point-to-point conventional circuit breaker, we can use an hybrid HVDC circuit breaker. This methodology of integrating a solid-state devices and a mechanical circuit breaker in a combined configuration is known as hybrid switching method. The hybrid design, it has several advantages over conventional circuit breaker used in HVDC system, which is it has very less loss while preserving the ultra fast current interruption capability, and the hybrid breaker also has relatively low contact resistance and hence low power loss, and also has better frequent switching ability. They also have a good overload capability that mechanically operated circuit breaker than a mechanically operated circuit breaker, and have good level of contact reliability. And the size and volume of a hybrid breaker, it is lower than that of a solid state breaker. Thank you.